Hello everyone. Today we are going to see about reinforcement learning and ML technique. You have me, Priyanka Narayanan from SRMIST Chennai. I'm doing my MBA second year and my faculty guide name is Dr. K. Prakash. So reinforcement learning is one of my favorite techniques or favorite topics since I started learning machine learning. So today I'm going to talk about reinforcement learning. Reinforcement learning, as I said, is a machine learning technique that enables an agent or a machine to learn in an environment. An environment, as in it is interactive, and through trial and error, it learns something, and using feedback and rewards, it is going to either repeat the action in order to receive the rewards or refrain from doing the actions in order to minimize the punishment or negative rewards. So I have told all these words, but for few of you it might be complicated. So I'm going to make term it into a simplified version. So as I told, RL is a learning methodology and it's a machine learning methodology. Who is going to learn? Who is going to learn is that a machine or an agent. Uh, okay, where do the machines learn from? It is going to learn from the environment where it is going to act. So once it's learning something, how it is going to actually get to know if it's doing the right thing is through the rewards for its actions. And it will repeat the actions or stop doing it. So from this, what do you get? It is understood that reinforcement learning is actually mimicking a human's life, and it's actually understanding something from the environment and keeping it in memory and doing it again or refraining from doing it. Similarly, human beings do some actions based on the rewards they get or the punishments they get, right? In order to avoid the punishment, we actually follow the law. In order to get the rewards, we actually work hard. So this is the same thing that the agent does in the reinforcement learning, or in other terms, reinforcement learning is framed in the same way humans learn to do something. It is based on the behavioral theory called reinforcement learning. So what does that reinforcement theory of motivation says? It has actually four types of reinforcement for every action a human does. So, what are the four types of actions? Is that one is positive reinforcement. Positive reinforcement, as in, for doing a work, you get a positive reward. For example, you write an exam and you get the positive marks or high grade. So that's a positive reinforcement. What if you don't write the exam properly or you have the negative marking in your examination pattern? For every wrong answer that you get a negative reward. So that is called extinction. So then what is called negative reinforcement? Negative reinforcement is that for doing the right action, you actually remove the negative consequences. So that is called negative reinforcement. And the next one is punishment. As you all know, when we do a wrong thing, we get a punishment. So, next is I'm going to tell you about how this environment or the model of the reinforcement learning works. We have an agent or the machine or any person that learns. Consider it like that. So for easy understanding. So agent is someone who's going to learn or a machine that is going to learn. Where does it actually work in? It is going to work in an environment. And what does it do? It does an action. And actually the state in which the agent is called the state of it's simply called the state of the agent, and for whatever action it does, it is going to get a reward, be it positive or negative. So that is what is given in this environment, in the diagram that you see. This is the overall model. In addition to this, there are two things called policy and value. Policy is actually the method to map agent state to actions, or we can simply call it as guidelines. So, guidelines or law. Simply, in simple terms, I have to say, for doing something, an agent is going to move into a different state. For example, I'm doing my PG, and then if I do my PhD, I'll get a doctorate. So, those set of rules and guidelines are given under policy. The next thing is value. Value is actually going to tell you about the rewards that an agent is going to receive for doing a particular action. So this is the overall model of reinforcement learning, or these are the basic components of reinforcement learning. In a simple analogy, I have given this picture which actually portrays a dog being trained. Let's keep the dog as the agent, and the environment for the dog to portray or to show its qualities is the human who's going to reward the dog for whatever he does, and the environment or the surrounding of the dog is actually consisting of the human. So human is also considered as a part of the environment for the agent, that is the dog. It is going to do some action, and the environment, the human is throwing a twig. So that's the actions and the situations are actually caused by the environment, and the dog is going to give an action or do something to in order to get reward based on the observation made by the environment. So this is the overall working of the reinforcement learning, or an analogy of reinforcement learning. Another way to explain reinforcement learning is a game. Any game is an example of reinforcement learning. You can take this Pac-Man game. So in this Pac-Man game, you can see that the Pac-Man, the yellow thing that's moving, it's going to collect all the dots, all the food that it's going to get, and it's running away from the ghostly figure. Ghostly figure is going to kill the Pac-Man. So it's running away from the ghostly figure. And if you can see, if the Pac-Man is eating a bigger white portion, it's going to turn the ghost into food, and it can consume the ghost as well. So being in one cell, taking the right direction is actually given to the Pac-Man's brain, or it's a policy of Pac-Man. So there is something called exploration and exploitation in reinforcement learning. So in order to build an optimal policy to make the agent decide where to go and where not to go, the agent has to face a dilemma, which is that it has to explore all the possible scenarios in that particular environment, while it also has to maximize the reward that it's going to get. So to balance both, it has to explore and exploit at the same time. But the thing is, it cannot do both the things at the same time. So that's why this trade-off comes in. To get the best overall strategy, sometimes the agent has to sacrifice the small time reward and focus on the long time action. So, this is what is called exploration and exploitation. To explain this in a simple term, I would give an example. Here, there are two people. Say you and your friend are going to dig the ground to get something valuable. Your friend is digging the ground and getting a diamond, whereas you are digging the ground and you're not getting anything. In that case, what will you think? You will dig in the same hole that your friend was digging to get another diamond. But whereas, like if you look into the hole in this picture, deeper in your hole itself, you can find a bigger diamond than your friend's is. So as soon as you find your friend getting a diamond and you are going to dig into that hole or that pit, it's because of the greed that you have. And this policy that the agent follows is called greedy policy. Greedy policy is simply nothing but it's going to maximize the rewards based on the rewards that it's getting. But actually, there are different scenarios. Like diamond may be present when your friend is digging, and when you're digging, it might take a longer time to get a reward. Or the other case is diamond present wherever you're digging, like the previous case that I told you. Or diamond is not present in either of the holes, and you have to dig somewhere else. So all these things are called exploration. Like the agent has to explore different pits in order to get the diamond. So in other case, exploitation is looking into something that you already know. So you know that your friend has got diamond, and you imagine, or you actually believe that you will also get something, and you fall into the false trap. So this is called exploitation. So exploration and exploitation can be done either at a time and not both. So to decide this, there is something called epsilon greedy policy that the agent can follow. So epsilon greedy policy refers to the probabilistic method where, based on a certain probability, the agent will decide to exploit or explore. Say, for example, you throw a die. The probability of getting 1 is actually 1 by 6. So 1 by 6th time, explore, and other times it will exploit. So this is how epsilon greedy policy works. So this is the overall picture about um, reinforcement learning. Now let's quickly look into the characteristics of reinforcement learning. Characteristics of reinforcement learning is that there is no supervision at all, as in case of other machine learning algorithms. It actually learns by itself based on the supervision of the environment or the reward it is going to get. It's not an actual supervisor. The next is making is actually sequential. It's not going to be like parallel at a time. It's going to take an action at one time and know if it's going to reward it in a positive way or a negative way. And the next thing is time plays a major role. Time plays a major role, as in reinforcement learning is actually exploring one by one, exploring state by state. So it's going to be time consuming, and the opportunity, say for example, in case of a car, the environment is going to be changing every time, so it differs from time to time. That's also a characteristic of reinforcement learning. And the next thing is feedback isn't prompt, which means it's not going to get the feedback then and there, but it's going to be delayed sometimes. The next one is uh, the data that it's going to receive after getting into a next state is actually determined by the agent's action. If it's going to do a negative action, it's going to get a negative reward and get into a negative situation. So that's what is said in the last point. And the next thing is, I'm going to touch upon the real life applications of reinforcement learning. We'll start from autonomous cars. And you know okay, so you know that reinforcement learning is game based, as I told you. So gaming itself is a real life example of um, reinforcement learning. We all know that there's something called bots that play the game. So bots can actually play a game better than humans. So depending upon the intelligence the bot has arrived, like say you and the bot is playing, and you are you're giving the agent different situations for it to face. As in, every time it fails, it learns something. It learns a new move and is getting better and better. We as humans can't remember, but the robots remember better than humans. The next example is autonomous cars, as I told you. Autonomous cars actually are coming under non-episodic situations. Non-episodic situations, as in only after getting into a particular episode and environment, you will know that any car is coming or any obstacles are there. So it's a very challenging procedure, and reinforcement learning obviously plays a major role in autonomous cars. It's actually trained to work in the dynamic world, dynamic environment, and it's experiencing new things and learning new things. And it is also trying to minimize the traffic consequences. The next one is traffic signals. Traffic signals, as we know, the traffic is getting worse and worse every day, obviously in India. And the traffic signals are automated based on reinforcement learning. Based on the traffic, the signals are going to decide, the traffic signals are going to decide if it has to put red or green or yellow. So this is automated, and the traffic police need not look into these things. These are actually implemented in different cities around the globe. The next one is robotic surgery. As we all know, these days robotic surgeries are getting improved day by day, and this is one such example. Um, Surgeons are getting aided by the robots that are actually working based on reinforcement learning, or that are being trained based on reinforcement learning methodologies. The next one is customized recommendation for customers, which is when you look into the social media, you get recommendations, ads based on your interests. That is also based on reinforcement learning, and also like when sometimes based on the purchasing pattern, the agent itself decides that you like certain ads, and based on the ignorance from your side for a particular ad, it decides that it shouldn't pop such ads for you. So that's coming under reinforcement learning. So I have touched upon all the major parts of reinforcement learning, and I'm waiting to tell you about other topics if time permits. Thank you.